What is a limiting reactant? A limiting reactant in a chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. The amount of product formed is limited by this reagent, since the reaction cannot continue without it. What is an excess reactant? Excess reactant is a reactant present in an amount in excess of that required to combine with all the limiting reactant. It follows that an excess reactant is one remaining in the reaction mixture once all the limiting reactant is consumed. So the first sample problem number 1 is, given the equation NO4 plus 2H2 2O2H plus NH2, which is the limiting reactant if 4 moles of NO4 reacts with 4 moles of H2. To solve this problem, we have to write the NO4 plus 2H2 per 2O2H plus NH2. So, in this equation, there is 4 moles of NO4, 4 moles of NO4. So, there is no coefficient, so we put 1 mole in here. Four divided by 1 equals 4. So, makancel pa ni sila. The answer is 4. So, there is in H2, 4 moles of NO4 reacts with 4 moles of NH2. So, 4 moles pod ang dere react sa H2. So, in H2O, there is 2 coefficients. So, 4 divided by, at the bottom, we put 2 mole. So, cancel. 4 divided by 2 equals 2. So, how do we define limiting reactant and excess reactant? So, limiting reactant is the reactant that limits the extent of the reaction and determines the amount of the product formed. Excess reactant, reactants that left over when our reaction stops. So, the limiting reactant is the 2. While the excess reactant is 4. So in sample problem number 1, we have the 2 limiting reactant and 4 excess reactant. So here's the sample problem number 2. What is the limiting reactant in the reaction between 3 moles of CO3 and 6 moles of Vs? The first thing that we want to do is to balance the chemical reaction. So, we need to put CO3 plus Vs, C2 plus V plus O2 as the coefficient of CO3 is 2, and Fe is 3, here also is 3, and 3. The second thing that we want to do is to determine the limiting reactant by dividing the number of moles by the coefficient. The reactant that gives a smaller quotient will be the limiting reactant. So, I'm gonna put, atong ibutang diri ang 3 mole of CO3, and then 2 mole CO3 also. So, kaning duha makancel. So, 3 divided by 2 equals 1.5. So, ikaduha, 6 mole of FeS, then 3 mole EFS. So, kaning 3 mole, kaning 3 over 2, asa ni lagi ko? Ang kaning 3, din hindi siya kaning mole sa CO, sa carbon dioxide o sa oxygen. Ang kaning 2 is the coefficient. Ang kaning 6 mole of FeS, ang kaning 6, diri ni siya gikuha sa Fa sa iron ug sa letter S sa sulfur. So, ang kaning pong 3, diri po ni siya gikuha. So, ang kaning makancel ni kaning sila duha. 6 divided by 3 equals 2. So, kani silang duha is from the balance chemical reaction. So, ato nang pangitaon ang limiting reactant. Ang nakabutang is the reactant that gives a smaller quotient will be the limiting reactant. So, limiting reactant, excess reactant. So, ang smaller quotient niya is maong si CO3 kay 1.5 raman ang iyaha niya. Ang kaning sa FeS kay mo ni ahang kuan ang excess reactant. So, CO3 is the limiting reactant, and FeS is the excess reactant. So, that's it. So, here's the sample problem number 3. We'll use this equation to answer these questions. What is the greatest amount of ElCl3 in grams that can be made with 114 grams of Al aluminum and 186 grams of Cl2 chlorine? Which is the limiting reactant? Which reactant is an excess of how many grams of it are left over? Okay, so to start out this kind of problem, the first thing we got to do is to figure out what the limiting reactant is. Is it aluminum or is it chlorine? To figure out the limiting reactant, we get to plug some stuff into this equation. And in order to plug things into the equation, We get to have them in moles. Okay, so we need to ask the questions. How many moles of each reactant do we have? Right now, the problem is giving us the right equation, right information grams. So, grams of ElCl3, grams of aluminum, grams of Cl2 or chlorine. So, we got to convert from grams to moles. Okay, so let's start with the aluminum. In aluminum, we had 114 grams Al. To convert to moles, we are going to use the molar mass of aluminum, which tells us how much 1 mole of aluminum weighs. We can look the molar mass of aluminum at the periodic table. Molar mass of aluminum is 26.98 grams per mole. So, I'm going to multiply 114 grams by 114 grams EL by this conversion factor. I want to get rid of grams, so in order to do that, I'm gonna put 1 mole at the top, 1 mole at the top, and then I'm going to put 26.98 grams AL at the bottom. So, makancel na ni sila si kani o kani. And I do this 114 times 1 divided by 26.98. So, the answer is 4.23 moles of aluminum. Okay, so that's how much aluminum I have now. Let's do the same thing for Cl2 for chlorine. Okay, I have 186 grams of Cl to I'll multiply by a conversion factor that expresses the molar mass of chlorine. Okay, so the molar mass of Cl2 is 70.90 grams per mole. Why is it 70.90? Because the molar mass of chlorine is 35.45. But because Cl2, we have to multiply it by 2. So that's why it is 70.90. So I'm going to multiply 186 grams of Cl2. I want to get rid of gram Cl2. I'm gonna put 1 mole Cl2 at the top and 70.90 grams Cl2 at the bottom. So, makancel po ni siya. So, ato ning i-multiply ang 186 times 1 divided by 70.90. So, the answer is 2.62 moles Cl2. Okay, so now we know how many moles of aluminum we have and how many moles of chlorine we have. So, in aluminum, we have 4.23 moles of aluminum and 2.62 moles of chlorine. We can figure out which of these two things is the limiting reactant. So, okay, we're going to answer two questions to figure out this first. We're going to ask the first reactant that we ran out of is the limiting reactant. We're going to figure out which do we run out of first. Do we run out of aluminum or do we run out of chlorine? To use all of the aluminum, how many moles of Cl2 do we need? Okay, we'll have 4.23 moles aluminum, and I want to multiply this by conversion factor that represents the relationship in this equation between moles of aluminum and moles of chlorine. So I'm going to put on the bottom of 2 moles of aluminum. I got the 2 in there, and then on top I put 3 moles of Cl2. I got the 3 moles in here. So the answer, we're going to cancel. So as you can see that we're going to be converting to Cl2 because the moles of aluminum cancel out. So 4.23 times 3 divided by 2. The answer is 6.35 moles Cl2. So we need 6.35 moles of Cl2 to use all of the aluminum. Okay, so what is this actually telling us? It is telling us that in order to use all of the all of the aluminum of the 4.23 moles of it, we need 6.35 moles of Cl2. Now we're gonna ask the same thing, but starting with all the Cl2 to all of our total amount. Okay, so we have 2.62 moles of chlorine of Cl2. I'm going to multiply that by conversion factor that shows a relationship between moles of aluminum and moles of Cl2. I'm going to put at the bottom 3 moles of Cl2, 3 moles of Cl2, and 2 moles of aluminum at the top. So cancel. So I'm gonna multiply this by 2.62 times 2 divided by 2.62 times 2 divided by 3. So the answer is 1.75 moles of Al. We need 1.25 1.75 moles of aluminum to use all of the chlorine. So which is the first reactant that we ran out of? Which is the limiting reactant? Okay, check this out. Alright. To use all of the aluminum, we need 6.35 moles of chlorine, but we don't have 6.35 moles. We only have 2.62 moles of chlorine, right? We don't have this much chlorine. On the other hand, to use all the chlorine, we only need 1.75 moles of aluminum, and we have more than that. We have 4.23 moles of aluminum. We can see this, we have enough aluminum to use all of the chlorine, right? We have enough aluminum. We have 4.23 moles of aluminum. We only need 1.75 moles. We have enough aluminum to use all of the chlorine, but we don't have enough chlorine to use of the aluminum. We need 6.35 moles of chlorine. We only have 2.62 moles of chlorine. So what does this mean? Well, if we don't have enough chlorine to use all of the aluminum, it means that Cl2 is the limiting reactant. Cl2 is the limiting reactant. The amount of Cl that we have is limiting the amount of product that we can make. It's the thing that it's holding us back now. Now, we want to figure out how much ElCl3 we can make. To do that, we can start with all the aluminum because we don't have enough Cl2 to start with all the aluminum. But we can use all of the chlorine. We have enough aluminum to use all of the chlorine. So we're going to figure out how many moles of ElCl3 we can make if we use all the chlorine, because we have enough aluminum for that. So starting with all the chlorine that we have, 2.62 moles of chlorine. We're going to multiply by this conversion factor that shows the relationship between moles of chlorine and moles of ElCl3 aluminum chloride. So I'm going to put 3 moles Cl2 at the bottom and 2 moles of ElCl3 at the top. Cancel. The answer is 1.75 moles of ElCl3. Now, we're not quite done with this part of the problem because we're asked the greatest amount of ElCl3 in grams, not in moles. So we get to take this amount of moles and ask how many grams is this. Okay, in order to do that, we're going to need the molar mass of ElCl3. As what I've said earlier, the molar mass of aluminum is 26.98 and the molar mass of chlorine is 35.45. Molar mass of ElCl3, 26.98 plus 3 times 35. grams per mole. Grams per mole. The answer of molar mass is 133.33 grams per mole. We can express it as a conversion factor, and just is we can use the conversion factor to multiply by this because I have moles of ElCl3. So 25 moles of ElCl3 times 133. Mare, naligo sa kadaan, Mare. 1 mole ElCl3 plus 233 grams ElCl3. So that is the first part of our question, which asks the greatest amount of ElCl3. Now there's one more thing that we have to figure out, and that is which reactant is in exist and how many grams of it are left over. To figure out this exist reactant, want to go back and want to ask how much aluminum do we need to react with the maximum amount of chlorine. We did this calculation earlier. Alright, we have the maximum amount of chlorine. This is how much aluminum we need to react with. Alright, because we have way more aluminum than that, so we have extra aluminum. That means that aluminum is the exist reactant, and we want to figure out first of aluminum how many moles are left over. Okay, so our exist reactant here is just going to be our total reactant minus the amount of reactant that we use. So we start with 4.23 moles of aluminum minus 1.75 moles of aluminum equals 2.48 moles of aluminum. Now this is still in moles, so finally we got to convert it to grams by pulling out the molar mass of aluminum. Okay, so we want to multiply this by a conversion factor. 2.48 moles of EL 26.98 grams of aluminum. 1 mole aluminum. Cancel. So the total answer 66.9 grams of EL. And this number here tells us that exists the amount of exist reactant, the amount of exist aluminum that we have left over.